So as I get to this lesson, I realize lesson 4 is not in your notes package, but it is right in your workbook. So lesson 4 is going to be done right in our workbook. Please turn to page 277 for lesson 4. Now, if I was there, I'd have a better feel for how much time we have left in class. But since I'm not really sure on that, we're going to skip this part with the algebra tiles. And we are going to go straight to this page 277. And what we're doing today is we're reviewing the distributive property, something you did in grade 9. So this should be a pretty sort of comfortable, maybe easy lesson for you. All right, let's take a look at this first one. So what we have here is we've got a monomial multiplying a binomial. This 2 that's outside the bracket, it has to multiply onto everything inside the bracket to give us 2x plus 2. Okay, same thing with this x. That x has to multiply onto everything in the bracket, giving us x squared plus 3x. Please go ahead and try the next one. So this time I'm multiplying through with a 2x. So on my first step of multiplying, I'd get 2x squared. I'm adding the exponents. And multiplying over to here, I'm going to get negative 4x. Okay, be careful on this next one. We've got a negative number. So negative 3 times positive x would be negative 3x. Negative 3 times negative 1 gives me positive 3. So that's one of those spots where it's very easy to make a mistake is on that sign right there. So notice when I'm doing my multiplying that I'm thinking about the sign. Negative 3 times negative 1 is positive 3. Now this next one is written in a little bit of a funny order, but it doesn't really matter. We could do this 2 different ways. We could say I'm going to take this x and multiply the 2x, take this negative 1, multiply the 2x. And that idea is kind of shown to you right here. So this b times a is ba, and then c times a is ca, but we want to put these in alphabetical order. So rather than ba, we should write it as ab, and rather than ca, we should write it as ac. Now, if that felt weird to you, taking the binomial and distributing it, you can also just take the 2x and distribute it. I think that's probably the most common way to look at it. So let's take that 2x times x, and that gives us 2x squared. And then 2x times negative 1 gives us negative 2x. Sorry about that hammering, you guys. I hope you can't hear it too loudly. And on to example 3. Says use the distributive property to determine the following products. So I think what we'll do is, Ms. Peters, if you could hit pause here, we'll let the students try these 4 questions. And then once everybody's done, please turn the video back on and we'll see how we made out. So I'll go through the steps here and I want you guys to just check your work compared to mine as we go. So on that one, things to watch for, making sure that's a negative 5x and that is a positive 30. So I'm going to do distribution, kind of feels like backwards. That's going to give me x to the 5 negative 2x squared. So this one, negative 3 times negative 2 is positive 6xy. And then negative 3xz. So hopefully that went okay for you. So a little bit of terminology here for you. Let's just read this part together. In the example above, we have written a product of polynomials. So they're talking about what we were given. So right here, we were given a product, which is things that are multiplying. And we took that product of polynomials and we wrote it as a sum or difference of terms. In other words, this one turned out to be just a regular polynomial. So we had a binomial there, just a sum of terms. All right, on to example 4, everybody. So what I want you to think here in example 4, because there's more than one operation happening, I want you to remember BEDMAS. Specifically for these questions, remember that you have to multiply first, then collect like terms. So when you multiply, it's kind of that feeling of getting rid of the brackets. So this first guy here has a very catchy little point at the beginning. This 6 minus 4 is such easy math that your brain might want to just do that 6 minus 4 automatically, but subtracting has to be left to the end. We are supposed to do multiplying before subtracting. So I'm taking this negative 4 and multiplying through the bracket. The 6 is unchanged. It's just still sitting there. And then the negative 4 times positive 8 is negative 32x. And negative 4 times positive 1 is negative 4. Now we can do the adding or subtracting, which specifically is collecting like terms. There's nothing to combine with the negative 32x, but the 6 and the negative 4, when I combine those, I get positive 2. And then on to B. So again, I've got all this multiplying to do. This 4 has to multiply through the bracket. This negative 2 has to multiply through the bracket. So everybody go ahead and try that first step. We're getting the multiplying done first. Then we'll do any adding and subtracting that we can do. So my first step will look like this. I'll have 8x minus 12, and then negative 2x plus 12. So multiplying is done, and now I can do the adding and subtracting. So let's put our x's together. We have 6x. And you know what? Our negative 12 and positive 12, we combine those, we get 0. So it's just 6x for that one. Okay, and then I'm going to get you to do the first step here again, where you're going to multiply this 5x through the bracket. And here, this is like a negative 1 that you're going to multiply through the bracket. So everybody go ahead and try the first step. Do all that multiplying and then hold your horses. Okay, compare your work to mine. Okay, really pay particular attention to the signs that we have here and here, because I'm multiplying by -1 through that bracket. Now I'm ready to combine like terms. So everybody go ahead and combine like terms. Make sure you get your polynomial in the best order. And then check your answer up here. Make sure if you've made a mistake that you are aware of how you made that mistake. And then we're on to number 5. So our last little bit of examples. And what we're going to do here is we're going to look at 2 different ways that we could answer this question. So we are finding the area, and we've seen these ones before, but just a reminder, area for rectangles is equal to length times width. And in part 1, we're going to find the area by adding the areas of 2 rectangles. And then in part 2, we're going to redo the question subtracting the areas of 2 rectangles. So when we get started here on part 1, we could divide it this way into 2 rectangles, or we could divide it this way into 2 rectangles. I actually feel like we've maybe done this one before. Maybe it was different numbers, or was it the same? Anyway, let's do it this way. Let's see how this one plays out. I'm going to call this rectangle area 1 and this one area 2. So to find my total area, I will have to find area 1 and add to it area 2. So area 1, length times width. And then area 2, here we'll have to be a little more careful, because for area 2, I do know the length, but I do not know the width. So I've got to figure out the width first. So take a look at this whole side right here. 4x for that entire length, 2x for this length. Now this side right here and this side right here, they match up perfectly with 4x. So this side and this side have to add up to 4x. And so that means this missing side here would have to be 2x. So back to area 2, it's going to be 2x times x plus 5. And you know what we have now that we've got this set up is we actually have a question that is exactly like example 4, question B. So remember to multiply first and then combine like terms. So there's the multiplying part done. And now the combining like terms to get it in simplest form. We'll put our x squareds first, 8x squared. Then we'll put our x's next, positive 14x. And remember to watch out for units. If there were units in this question, we would say units squared. Okay, in part 2, we are going to use the subtraction method. So what we're doing here is we're pretending that there's this full rectangle. And to find my total area, what I'm going to do is I'm going to take that full rectangle, and then I'm going to subtract the part of that rectangle that we don't actually want to include. I do not want to include this area because on the original diagram, that area did not exist. So we're going to do the area of the large blue rectangle, which isn't too tough to do because, again, we know the length and we know the width. So let's get that one set up. 4x times 3x plus 2. Now the little red one is going to be a little bit trickier, although we could steal some information from what we already know. So when I did method 1, I figured out that this would be 2x. But I also need to figure out this side right here. So notice how this entire side, 3x plus 2, it's going to be the same length as this entire side. Oh my goodness. Hopefully that's over. So let's figure out what's missing here so that this entire side would be 3x plus 2. All right, so I'm going to need, I've already got an x on this side. I'm going to need 2 more x's because now that it'll match up with that 3x. I already have a 5, but I really only want a 2, so I'd have to subtract 3. Now, if you checked your work here, this plus this does equal this one. All right, we're ready to roll. So on the red rectangle, 2x times 2x minus 3. And let's give this a try. So multiplying first. And then remember here we're distributing a negative 2x. So negative 4x squared plus 6x. And when we get this in simplest form, putting the x squareds together, I get 8x squared. Putting the x's together, I get positive 14x. Exactly what we got using the first method. All right, we're ready for an assignment, guys. So you are doing the questions that are in red, and these questions start right after these examples. So just in your workbook, number 4, number 6, number 7, A, C, and E, and number 10. So that's all from me for today, everybody. Stay strong, be kind, and have a great weekend. I hope to see you on Monday.